Hello everyone. Today we'll be looking at question number 30, GATE 2020 for chemical engineering. Consider the equilibrium data for methanol water system at 1 bar given in the figure below. A distillation column operating at 1 bar is required to produce 92 mole percent ethanol. The feed is a saturated liquid. It is an equimolar mixture of methanol and water. The minimum reflex ratio is dash. And the four given options here are A 0.33, B 0.50, C 0.54 and D 1.17. So this is a question from distillation part of mass transfer operations, and the reference lecture from NPTEL can be obtained in lecture 3, week 9, number of trays by McCabe and Thiel for distillation, mass transfer operations 1 by Professor B. Mandal, Department of Chemical Engineering, IIT Guwahati. So let us take the graph and the given data in a separate page. So we have been given the data XD is equal to 0.92, which is the mole fraction of the distillate. We have also been given that the feed is a equimolar saturated liquid. So that means the feed fraction Q is equal to 1. The operating line for feed section we can write with the equation y is equal to Q by Q minus 1 into X minus XF by Q minus 1. So from this equation we can say that slope of the feed line or the Q line is equal to Q by Q minus 1. And substituting the value of Q as 1, we'll get slope of the feed line as infinity. Now we'll mark these points in the graph. So first they have given that feed is an equimolar feed. So feed mole fraction XF is equal to 0.5. And now we just found out that the slope of the feed line is equal to infinity. So this basically means that the feed line is a line that starts from x is equal to 0.5 and it is basically a vertical straight line. So this vertical straight line intersects the equilibrium curve at the point 0.5, 0.78. Now we can also draw the operating line from starting from xd is equal to 0.92. At minimum reflex ratio, these operating lines will intersect at the equilibrium curve. So we can write that at minimum reflex, all the operating lines of enriching section, stripping section, as well as the feed section will intersect at a point on the equilibrium line. And this point here is 0.5, 0.78. So xy is equal to 0.5, 0.78. Now, if we write the operating line equation for the enriching section, so this we can write it as y is equal to r by r plus 1 into x plus xd by r plus 1. Now, we just have to substitute these values. So since these lines are intersecting, we can substitute the x and y as 0.5 and 0.78 and xd is given as 0.92. So substitute these values, we'll get a linear equation with the only variable as r. So solving this equation, we'll get r is equal to 0.5, which is the minimum reflex ratio. So the correct answer for this question is option B, r is equal to 0.5. Thank you.